Hi students, welcome to physics classes. Today we'll discuss about sound, basics of 8th class physics, which is helpful to learn 9th class. Okay, now sound is a form of energy. Sound is a form of energy. Now in physics, as we know, we won't use a word energy until it do any work. What is mean by energy? Capacity to do work. Energy means capacity to do work or ability to do any work. So here, to say sound is a form of energy, it should do some work. What work it is doing? Sensation of hearing. It produces a sensation of hearing in our ears. Okay, and even it can produce vibrations. Sound is produced by vibrating bodies. Sound is produced by vibrating bodies. And sound energy creates vibrations in eardrum. Then we can sense that sound. A vibrating body can produce the sound and a vibrating body can listen the sound, identifies the sound. For example, here whenever we are talking, vocal cords are producing vibrations. So sound is produced. Due to that sound, eardrum gets vibrates. Then we can listen that. Any vibrating body can produce sound, and every source of sound is a vibrating body. Without vibrations, there is no sound. Any vibrating body can produce the sound, and every source of sound, wherever we are listening the sound, that is a vibrating body. We are talking, vocal cords are vibrating. If you are listening sound, music, speakers, there is a membrane which will vibrate. Okay. Every vibrating body can produce the sound, and every source of sound is a vibrating body. Now, how sound will be propagates? Now, if any person speaks, now I am talking, air near my mouth, for example, here I am talking, source. Air near the source or my mouth is get disturbed. Means I am releasing the sound energy. I am releasing the sound in the form of energy. That energy which is entered into the air creates disturbance in the air. And these air molecules starts vibrating to and fro like this. Going forward and coming back, going forward and coming back. And it will hit to the neighbor molecules. And it will start vibrating. And that hits to the neighbor molecules. It starts vibrating. Like this process continues till it reaches the listener's ear. And finally, this energy entered into the eardrum and it makes the eardrum to vibrate and it can be converted into sound. Transfer to the brain and we can identify that sound. Sound need a material medium to travel. What is mean by medium? Anything can be a medium through which sound can travel. Anything can be a medium. Air is a medium because sound is traveling through it. Water, liquid is a medium. Through it, sound is travels. Gas is a medium. Solid is a medium. Wall is a medium. Means the substance through which sound can travel. The substance through which sound can travel is called a medium. Example, solid, liquid, gas. Through gas, sound is traveling. So gas is a medium of sound. Liquid is a medium of sound. Solid is a medium of sound. Sound compulsory needs a medium. Because as we discussed earlier, sound in the form of energy and when it is entered into the air, it creates the disturbance. Due to that, molecules gets vibrate and it will hit to the neighbor molecules. So sound is passed to the neighbor molecules and that will vibrate and hits to the neighbor molecules. Sound is passed to the neighbor molecules, like that it should go. So it requires a material medium. It requires a material medium and it cannot travel through vacuum. Vacuum means no medium, no gases, nothing is present in that, no medium. So sound cannot travel through vacuum. Now speed of sound in air nearly equal to, not exactly, it depends upon the temperature. If temperature changes, speed of sound also changes. That's why nearly equal to 332 meter per second. In liquids, example water, nearly equal to 1500 meter per second. Solids, nearly equal to 5100 meter per second. These are not exactly, these are nearest values. Nearly equal to, the symbol nearly equal to. Okay, next frequency. Now sound travel in the form of vibrations. The number of vibrations produced in 1 second, in a particular time, in 1 second time, how many vibrations are produced, that becomes a frequency of sound. It is measured using units hertz. Hertz is a scientist name. While writing complete name, we should use small alphabet, symbol capital alphabet. For example, if you say the frequency of the sound is 200 hertz, means in 1 second the source is producing 200 vibrations. 200 vibrations, 200 waves, or 200 cycles. Vibrations, cycles, waves are same. Calculating the vibrations and time is fixed. In 1 second, we are calculating number of vibrations produced is frequency. If you reverse it, vibrations are fixed, one vibration. Time we are calculating, that becomes time period. Time taken to complete one vibration, one wave, one cycle is known as time period. Time taken to complete. Unit is second. Time period is measured in seconds. Now the relation between frequency and time period, frequency equal to 1 by time period, or time period equal to 1 by frequency. We can denote frequency with n. Now based on different ranges of frequency, we have different sounds. Range of frequency of sound. Now if the frequency is less than 20 hertz, infrasonic sounds. Those sounds are infrasonic sounds. If the frequency is between 20 hertz to 20,000 hertz or 20 kilohertz, is sonic sounds or audible sounds. These sounds we are able to listen. Human can identify these sounds. And above 20,000 or 20 kilohertz is ultrasonic sounds. Ultrasonic sounds. Next, some terms related to waves. In that first one, amplitude. Now when the wave is taken, we have two types of waves. Longitudinal wave, transverse waves. Now here I have taken transverse wave. Here, when the energy is propagating in horizontal direction, wave is vibrating up and down. Particles are vibrating up and down. Perpendicular. Particles vibration, energy propagation, both are perpendicular to each other. Here, these molecules are vibrating up and coming down. So this maximum displacement of the vibrating body. Maximum displacement of the vibrating body. Maximum means this one, no? This is known as amplitude. It is a mean position. From mean position, the maximum displacement is known as amplitude. We can measure amplitude in meters. Now, length of a complete wave from here to up one is known as crest, and lower one is known as trough. Crest, trough. Okay, now the length of one complete crest and one trough is known as wavelength, or the length between two consecutive crests. The length between two consecutive crests is known as wavelength, or the length between two consecutive troughs is known as wavelength. Means one complete wave, or the length between crest to next crest or trough to next trough is known as wavelength. Next, speed of wave. Wavelength divided by time. We can write V equal to lambda by t. With what speed wave can travel? Wavelength by time period. Wavelength by time period. Time taken or time period is speed of the wave. Speed of the wave is denoted by V. Wavelength is lambda. Time period is t. Now, frequency is 1 by time period. Frequency equal to 1 by time period. If you substitute this formula in the speed, as we have speed equal to lambda by time period t. Now, instead of this, write 1 by t into lambda. We can write it 1 by t into lambda. Now, instead of 1 by t, we can write frequency. So, speed equal to frequency into wavelength. This is the relation between speed, frequency and wavelength. So, V equal to n lambda. Now, characteristics of sound. As we know, amplitude and frequency, those are related to loudness and pitch respectively. Now, if the sound is having more amplitude, it is more loudness, having more loudness. If the amplitude is less, it is a soft sound. If a frequency is more, sound is high pitch. Frequency is less, low pitch. Next, reflection of sound. Now, like light, when the sound hits any obstacle, it gets back into the same side, same medium. Now, if you stand in front of your mountains, hills, or any tall wall, sound gets reflects back. If you say hello, after 1 or 2 seconds, you will get hello back. Hello back. That is known as echo. The reflected sound from a tall wall or mountains, hills, closed room is known as echo. If you say hello, you will get hello, hello like that back. That is echo. Now, the minimum distance to form echo, for example, if an observer stands here, sound should go and come back to him. The listener, the observer, will listen his sound and reflected sound. Whenever he is saying hello, he should listen when he say hello and then reflected sound. If these two sounds, one is he is producing and another one is reflected, if this sound gap between them is 0.1 second, a human can listen two sounds if there is a gap. Minimum time between them is 0.1 seconds. Then he is able to listen that sound. So whenever we say hello, if it comes fastly, less than 0.1 second, we won't get echo. We won't listen echo. So if the sounds gap between two sounds is 0.1 second, minimum is 0.1 second, then this listener can listen the both the sounds. Once if I say hello, when I say hello, hello, I can listen. Then it reflects back. Then again I should listen that same hello. If both comes at a time, I can't identify. Human brain can't differentiate. So gap should be 0.1 second. To get this echo, the minimum distance should be 17 meters. minimum is 17 meters, more should be, and wavelength of the sound is less than height of the reflecting surface, and sufficient intensity should be there. It should go there and should come, no? So it should have some intensity. This is about sound lesson in the 8th class, which is helpful to learn 9th class sound lesson. Okay. Thank you for watching. Please subscribe.